Sure.
Everyone, Tom Johnson.
Thanks. All right. Thanks for inviting me. And I've been working on this API documentation course, so I had a lot of content that I've been refining and editing and preparing. So it's not as if I had to come up with a whole presentation from scratch. This is something I've trying to finalize a bit. But before I jump into this, I want to first find out how much you all know about API documentation so that I can, have a good conversation. Raise your hand if you've ever worked on an API documentation project. So 1, 2, 3, 4, 5, 6, 7. Half of you, at least. All right. And the other half, are you just interested in learning about API documentation or just kind of attending to attend? Any particular? Okay. Want to learn it?
Yeah.
There's a lot of opening there kind of for API.
Exactly.
Never had the opportunity to work on
Okay.
it. Not that it cannot be learned, it just never had the
Yeah, never really had the
never
opportunity.
tried it, yeah.
So this presentation is really geared towards introducing people to API documentation. I'm going to touch on some of the fundamentals. And for people who are more advanced, I invite you to jump in and challenge any kind of assumptions. I really invite people to interact and make comments because that's the whole point of a presentation. I have a lot of this online. If you go to my site, I'dRatherBeWriting.com/learnapidoc. I've got this course that I've been refining, as I mentioned. So, and you can find these slides online right here at this URL. So, all right, with that said, let's jump into a little bit of intro. Why is API documentation so important? I was just talking to one of you before who mentioned he'd been at a LavaCon conference where a lot of people were doing DITA. API docs tend to not use DITA as much. They tend to be custom websites that companies develop that have incredible amount of UX behind it, that look really sharp. They have professional user experience designers because the documentation, it is the product. There's not a separate software interface that people use and then maybe they go to the docs if they get stuck. That's not how it works at all. You start in the documentation. So if the documentation looks bad and it's hard to navigate and it looks like it's done up in an old PDF or an ancient sort of web design, it doesn't speak a lot of confidence to the developers, right? You want to look awesome, have an attractive interface that people can easily navigate, and most of the power-playing tech companies do. The growth of web APIs has really skyrocketed. And when we say web APIs, there are generally a couple of different types of web APIs. There's a REST API and a SOAP API, and REST is the predominant one. There are lots of other types of APIs, for example, a Java API or some JavaScript library that you incorporate. So 10 years ago, the traditional way that you kind of got functionality out to people is you created a library that they incorporated directly into their project. They downloaded it, integrated it, and then they could reference calls and classes and functions. Now all of this happens over the web. So the web itself is this services mashup. When you want a service, almost every company has an API to deliver that service to you. For example, if you want to build a website, you don't really just buy a giant Swiss Army knife type of site. You have a basic site and then you leverage all these different services through their APIs. If you want a form or you want comments or you want payment, they can all be pulled in through an API because the web is just this conglomeration of APIs that overlap. All right, so let's jump in.
So a lot
Yes.
of people make WordPress sites.
Yeah.
How does that translate into that world?
Well, even a WordPress site. Let's say you want search on a WordPress site. You can install a plugin that will maybe have some code that just gets installed, but if you want a more powerful search like SwiftType, Algolia, those sites actually work through APIs. You index your content. You push them an index of your content. Somebody creates a search, and when they click search, a call goes out to that index that's stored on their site, looks through the content, pulls back the results. So it's this interaction that's going away from your site and then back to your site. Obviously, a lot of other services might not work like that, but some of the more powerful ones, payment, for example, you integrate a payment processor and it's going out, getting information, pulling it back. But an API is kind of like this. I like this graphic. If you look at the gear in the middle, an API is basically something that allows two different systems to interact. Going with this example of the search, you have your website and somebody executes a search. The API goes out to this other search service, gets the information, and pulls it back. The API is this little component that brings the two together. Another example, if you think of your calculator, something as basic as your computer calculator, and you start pressing buttons, well, there are little functions underneath that are firing off off routines that perform actions and bring back the data. With a calculator, all that's internal. But the idea is that people who create interfaces have lots of buttons and things to click on the interfaces, and when you click those, the underlying wiring are these APIs that are going out and getting information. So the basic model kind of looks like this. You've got some application here. It could be anything, Ruby, Java, PHP. It's language agnostic. It makes a request out to some resource in the cloud, and that server, that API server, could be anything, Java, PHP, Ruby. It doesn't matter. This request goes out through HTTP protocol, right, which is the same protocol you use when you surf the web. You go to a website. And the response also travels through the same protocol, and it usually comes back in JSON. A sample request might, if you had maybe some, fictitious API about homes, some API address like coolhomes.api.com/homes. It does a GET request, pulls back a list of homes, something like that. The model of the web is very similar, right? You've got a browser. Let's say you go to a website like I'd rather be writing.com. You're making a GET request for this resource. The information is coming back. Your browser is saying, let me make this look friendly, but essentially it's the same thing. It's just delivering a bunch of HTML. So because the web itself follows REST, a lot of the principles about REST should be somewhat second nature. All right. So I like to think of a sample scenario. In this API doc course, I start out with a section on how a developer might use an API in the most basic example I could think of. Let's say you've got a website. Because I bike, I really want to know how windy it is. Because if it's really windy and if it's a headwind, it's a terrible biking experience. So let's say I wanted to create a little app that would tell me basic information about how windy is it. And I want to display the speed, the direction, and maybe how cold, I don't know why the chill is important, but how cold the wind is. Well, obviously, I'm not going to be measuring this and hard coding my app. I need some kind of service to go out and retrieve the information on the web and pull it down when somebody opens up the app. And I would find a simple weather API. Now, for the purposes of simplicity, you could come out to this site. This is a marketplace of APIs called Mashape. And this is a very simple weather API. There are dozens of weather APIs. A lot of them piggyback on larger services. And this one piggybacks on this Yahoo weather service. And so you can see the documentation here is very basic. You've got several endpoints. You probably can't read them, but it says AQI, weather data. You've got some endpoint definition, request example, parameters, and so forth. And this is a very simple version of what API documentation tends to look at. So a developer would say, does this have the information that I want? And the developer goes and gets some keys that will authorize the call. Not all APIs require this, but usually they want to have some kind of gateway or authorization methods so that not any service can just randomly hit them a million times. Obviously, they also want to charge for access. So you get the keys, and then you start making some requests. There's one app that's really common called Postman, and let me just bring this up here. This is an incredibly useful tool for submitting requests. You basically enter in information in the top, kind of like the resource URL, some parameters, some header keys, and then you can fire off the requests. You can click send, it goes out, and it returns the information. So right now, let's see, what is the wind? 6.44 something, whatever units that is, right? You can save all these requests. So I mentioned there are several endpoints in that API. There's one just called weather, returns some different information. You click that, you can see the temperature, partly cloudy at Sunnyvale, and so forth. Postman is a very useful tool, but it's more for testing and exploring and experimenting. You can actually put little buttons in your website that kind of open up all your content in Postman and import it. But by and large, when you represent how to make a request, you'll use something called curl. You heard of curl? Anybody? Okay. So curl is a way, it's like a command line utility for interacting with websites. And if you show a user how to make a request in curl, they can get all the same information that I was showing in Postman. So curl, let me...
Postman is really just human readable curl.
Yeah. And Postman is just one GUI client of many. There's one called PAW for Mac and a dozen others. Postman is pretty popular because it's free and it works on any platform. Yep.
So curl is a command utility for the resource locator?
Yeah, exactly.
It basically is kind of like sending it sends a request, makes a few requests from the command line.
That's the get and then
Yeah.
include.
Yeah, so we've got, this is what you would execute on the command line. You've got curl, you've got the method, and I'll talk more about these. I'll dive into these in a minute. I'm just kind of giving you the overview. You've got some other parameters here. We want to include maybe the header response and so forth. Anyway, the idea is you've got the resource URL for the API, some stuff that will be passed into the header, namely a mashape key, and what kind of format we'll accept in the request. So if I copy this and come into my favorite terminal, oops, I was doing some tests, okay. iTerm is one I really like. Paste this in here, you can see I get back all this JSON. Now it looks minified and unreadable, but that's what computers want, right? And you can prettify it and expand it so that it's readable, but you don't really need to do that here. In fact, actually you can even pass little parameters in your request that will minify it in this UI, but we don't need to do that. Okay, now curl has a bunch of options. When you start looking into curl, you realize that there's all these parameters. And there's like 50 or 70 different parameters, I think, or more. The ones that are most relevant for REST APIs are probably here. What you want included back. If you put a little -i in the command, it will return the header, which is metadata about the information, the status code, any other kind of thing like the format, the date maybe. Data, if you're submitting data into it, you can add a data parameter. This is important if, for example, your request that you're submitting has this huge request body content that you have to pass in, and it doesn't really fit in a URL. The -h refers to stuff that you have in the header of your request, and then the method. All right, so developer kind of plays around with these requests through Postman, curl, and you get back JSON almost all the time. It used to be that you could choose JSON or XML. Almost always now it's JSON, except in some industries that are might use XML, like financial or banking institutions. So JSON, it's important to kind of understand a few details about JSON because you will be describing JSON in your documentation. JSON consists of key value pairs like this. This is called an object when you have the curly brace that starts and ends it. And when you have the square brackets, it's called an array. And developers would need to know what the shape of this response is so that they can know how to pull the information they want out of it. There's a really nifty thing that's very common, and that's logging a response to the console. So when you make a request, you can actually log the response directly in your console and check out what comes back. So I've got a page here, and you can't see it because this is the HTML view, but behind the scenes I'm calling that same object that I did in Postman. I'm going to open up the JavaScript console, and you can see that I've got back an object which I've logged to the console, and you can expand it in these nice little tools here and see what kind of stuff comes back. Here I've got information about the weather, the unit, and here's my wind information. So as a developer, I'd want to know, yes, this is what I want. I want the speed of the wind. And see this, Chrome actually gives you a little tooltip on how to access this. This is called dot notation. And if your developer were using JavaScript to access the JSON, which just stands for JavaScript Object Notation, you would use a little dot notation like this, and it would pull out that specific value into wherever you want. The end result is going to look something like this. Now this doesn't have all the fancy graphics that I was showing, but if I click this little button, it goes out, and it gets the values for each of these, wind speed and so forth. And I could integrate this into a fancy weather app that had all kinds of different things. It shows you the forecast, the wind, and all this in a more graphical display. But that is just kind of a whirlwind tour of like how a developer might use an API and integrate some aspect of information into it. Questions, comments, thoughts? Yes, Joe.
Comment about JSON. One of the main reasons that REST APIs return JSON, or that's one of the preferred formats, is that excuse me, REST APIs are very useful in web applications, and so you can write the way to write web applications into a page is to use JavaScript. And if you were to look at the source of something, of a web page that you download from the internet, like something that has shopping cart or something like that, you'd see JavaScript all over the place. And the great thing is that if you get back a JSON object from a REST API, you can immediately convert it into a JavaScript object. There are built-in functions for doing that.
Yeah.
So that you can then use the result as a JavaScript object that you can get into through documentation.
Yeah, thanks. Yeah, exactly. Exactly. The JavaScript just fits really nicely into all the web applications. All right. Now I want to jump into more of the documentation. If you change hats and think, okay, I'm no longer really a developer person interacting with an API. I'm a technical writer. What do I need to know to document an API? Well, at the heart of an API is an endpoint. And an endpoint, these are these resources that you access through these URLs. There's typically about 8 different parts of endpoint reference documentation. Even though API sites differ drastically from site to site, I guarantee you almost every one of them always has most of these elements. Sometimes they don't show the code examples, but they have code examples somewhere. They may not always indicate all the status and error codes, but most of them should do that at least somewhere. So as you go through API documentation, you can create a little template like this and start filling in the blanks for each one. And I'm going to go through each of these, and we're going to kind of just briefly see what they're all about. So the first one, resource descriptions. This is information that the resource contains, and you usually put a brief 1 to 3 line sentence, start up with a verb, and let's look at an example. If you look at the Eventbrite API and go to their events search resource, you can see the description right here. Allows you to retrieve a paginated response of event objects from their directory regardless of the owner, and so forth. They often start with a verb. Oops, let me come back here.
Just get rid of the allows you.
They start with a verb if you want, but by and large they're brief. You know, they're not more than a paragraph. Now, exactly what you call these things varies a lot. If you look for resources in an API, it's not always going to be called that. You will find that the terminology is kind of all over the place. Some people call them endpoints, API methods, calls, resources. Some people don't have any name at all. They just kind of list a bunch of stuff and they assume you know what they are. But by and large, people refer to them as resources. Because the second part, resource URL, is kind of a more standard sort of term. And this is the path that you use to access that resource. Let's look at an example here. This is from, what's this from? Instagram. All right, so you can see they've got the path here, user self follows, user self followed by, and so forth. See, now they call them endpoints here, all right? So, and they don't necessarily say or set off each section with, hey, this is the resource URL. But in the documentation, you tend to have to describe things or refer to them, so you need a name. But here they've grouped a lot of the information under a nice big bold heading set off by the resource URL. You typically don't include the base path. That's all the stuff that comes before, because at some point in the API, in the introduction, you've mentioned what that is, and it just becomes visual clutter. Okay, let me close some of these other pages.
That sounds like generally you want those descriptions to be as concise as possible.
Yeah. I mean, developers like brevity, but also it's more of a reference. If there's a bunch of gotchas, workarounds, other tips, typically what you do is talk about that in more of the user guide, or the other parts of the guide. This is more like just the core reference. All right. Now, in your resource URL, if you have path parameters like this, somebody has to pass in a campaign ID. They're typically set off with curly braces, although not always. And sometimes it's hard to even differentiate what they are. So if you do have the ability to color code them, it helps set them off. All right, the next part is the method. And this is the operation that's allowed. For the most part, in that weather API, it's all get. And when you go to a website, you're making a get request. You're just getting the information. Because obviously, you don't want anybody to go and just delete or update your content, right? But when you have an API and people are authorized, then usually they can interact with the information. They can make updates to information. And so you have to tell what sort of operation or method is allowed. Let's look at an example here. This one's kind of interesting. This is MailChimp. And if you look here, they've sort of grouped their methods under read, delete, and action. So even though you just have one resource, emails, it's got a bunch of different stuff you can do. You can read, and this is the resource URL. You can see they've got a path parameter right here with workflow ID. That would be something the developer passes in order to configure it. Not all of them have snazzy little nav tabs like this to navigate things, but and it depends really on your API. You may not have a bunch of different methods per resource. Maybe you just have one. But if you do, it will definitely influence the way you organize things. If you have a resource that has 6 different operations and so forth with slight variations, but they're all related to the same resource, it's going to influence how you group and organize things.
Sorry, what site that you just showed?
This was MailChimp. Yeah, this is another great example. If you take any company and just Google their name plus API, you usually find their API. They usually have one. It's like, give me an example. Throw out any. Let's go for IHOP. Let's see IHOP API. That would be the ultimate. IHOP Web Services.
Yeah.
That would be funny.
Maybe it's not International House of Pancakes.
Yeah, sorry. Now I don't know where I'm going.
Yeah.
Probably not a great idea. All right, but for example,
How about Facebook?
oh, of course, Facebook's got an API. That's not even.
Amazon, Twitter.
I'm saying not even a tech company. Anyway,
Oh.
all right. Just generally, you'll find a lot of APIs. In fact, in my course, I have a list of about 100 that you can check out that I've just sort of been grouping just to compare how the different groups do the same thing. Okay, parameters. This is probably the most important section for an endpoint. And the most interesting, because the parameters are options that you can use with the endpoint to configure it. You, for example, add a certain ID at the end, or you add other kind of values that determine the type of information returned in the response. Let's look at an example with Box, the Box API. Yeah.
No, I was going to point out that Home Depot has an API.
Home. There you go. Awesome. Okay. Is that so? Can you use it in the store when you're lost and you're like, "Where is this mail?" That's what I want.
You can't actually have it.
There's product details, types of products, availability in store and online, and product dimensions.
Another store that has big time APIs is Walmart, and all these stores that have all these products. I mean, if you think about it. All right, so we're looking at parameters here, and in this Box API, which by the way uses readme.io, if you remember Greg, can't remember his last name, Kowalczyk or something, presented here on this. Anyway, so here they've got the parameters grouped into 3 different categories: path params, and of course they're cool enough they don't have to spell out parameters. They're like path params, body params,
Well,
and
remember who your audience is.
that's right.
We're not talking about users who are like trying to figure out how to use Microsoft Word. These are developers
Yeah.
who already supposedly know, who it's you generally assumed are software developers that know what a param is.
Yeah, who's got time for 4 syllables?
You can see
Well,
here.
I mean, it's not only that. It's not just that it's time for 4 syllables. It's just that
It's brief.
developers have a certain, they're used to having, looking at certain words, having a certain attitude and style and voice in documentation that they read. They're going to be turned off by the same voice that you might use for an end user.
Yeah. And at the heart of it, they want information really succinctly, easy to scan, and yeah, params is totally welcome. Well, you can yeah.
Sorry to interrupt.
No.
But I imagine, like, the environment they're in and the mode they're in
Yeah.
is accomplishing a task right there.
Yeah. Yeah.
So
Yeah.
they're in that mindset of hurry, get it done.
Yeah, definitely. And a lot of times they'll consult the reference documentation to know maybe the data type of the parameter, or was it camel case or underscore, how was this written? Was this a Boolean? But here, if you look at this path params, you can see that they've actually set off this path param by making it a tiny bit darker and underlined, which is not a whole lot of visual distinction, but they definitely set off the parameters, and they try to describe what they are. This is an object, this is a string. You don't have all the data types that you do as with Java, but you do typically have, let's see, you have these data types. You've got a string, integer, Boolean, object, pretty much. If you've got something more specific, you might but typically when you're passing your request, this is all that sort of matters. A string is some text, integer is a whole number, Boolean is true or false, object is key value pairs.
What about array?
What?
Array.
Oh, yeah, that might be one as well. Good point. Now the order is not really important. If you look here, here's a couple of different endpoints. Right after the question mark, this is called the query string. Right here. This is the query string. And after it, the parameters can be in any order. You could have units in the middle, the end, whatever. But if you have a path parameter, which is any parameter that comes before the question mark or the query string, that order does matter. You couldn't just put beach ID in front of something. So yeah, and if you're playing around with an API, it's fun to try to break it, and you can do it by passing bad parameters. You know, what happens when I put time equals 1 o'clock? What happens? That kind of information is usually good to note. Now the request body parameter is a little different beast because you don't pass that in the URL. You pass this in the body of the request. So if you're using curl, remember I had that -d, and you might refer to a file that has this information, or you might actually have this information included, minified, right in the curl example. But sometimes APIs have huge amounts of information you have to submit in there. Like if you're configuring a service, a whole server or some kind of service, you might have dozens of different things. I worked on one API that had like hundreds. It was ridiculous. And it was a real challenge to figure out how the heck we document this. All right, next example is the request example, or the next section is a request example. This is simply a sample request that shows basically how to make a request to this resource. And here's an example. This is Twitter's API. You can see down, where is it? They actually bury it. There we go. And it's not very well styled at all. It's kind of weird, but that's their request example. It's like they just threw that in there. And this is probably not the best example, but it kind of highlights some difficulty. When you look at this, if you can read it, when you look at this, how do you really know what's a parameter and what's the name of the parameter? Like screen name equals Twitter API. I assume Twitter API is the parameter value.
Left of the equal sign is.
So they're probably like, yeah, anybody who's using an API is going to know this. But sometimes it gets confusing, and it would help if they set these off in a different color, you know.
Yeah.
So if it's on the right side of the question mark at the end of the list JSON, that would probably be the stuff that's below it. Would
Yeah.
be some of your parameters, right?
Yeah, your query string parameters.
Exactly.
But if you had, anyway, you want to show just a general example. Now, you could have a lot of different parameters, like skip status. That is passed here. I don't know if they've got all the possible parameters shown in their example. Like, for example, well, maybe they do. But you might have a dozen different parameters that wouldn't make sense to all include in the same request. So your request is just an example, not comprehensive of everything you could possibly pass. All right. I think
That's a terrible API.
well, a lot of people,
Downvoted.
yeah, they use Twitter as an example of what not to do with APIs, I think because they've changed it so much. And every time you change an API, it breaks people's apps, and people don't like that, which is a whole other discussion, right, about getting it right the first time. But
Well, I noticed it had a version number in the.
yeah,
That's not untypical,
No.
especially if you have to maintain more than one version of an API.
Yeah, right.
But saying that the final part of your path is list.json instead of list/list/json.
yeah, it's a little odd.
Strikes me as being
List dot.
more than odd.
And you know, when you're documenting an API and you notice that, hey, we're calling one parameter one way, we've got a dot in it. In another example, we've got a full uppercase. Another example, we've got camel case, or you you're calling it something here and the same thing you're using a synonym, but it's meaning the same thing. You can make that kind of feedback. People appreciate that. If you're early enough in the design, you can influence change. But if you're too late, you just have to basically document what people have already coded and put little apologetic notes around your documentation.
Well, if nothing else, if you call out that sort of thing, you'll get brownie points for understanding what you think you're looking at.
Yeah, yeah.
There's a lot to be said for gaining the respect of your engineers by understanding what you're talking
Exactly. I mean, just the mere fact that you'd be making the requests and verifying that what comes back is maybe what some engineer had given you is a step up in the game. Yeah.
So as a technical writer doing API documentation, do you do like inline comments or?
Typically no, because the code. You mean in the code itself?
Yeah.
No, because the code is not something that they're pulling into their project. That would be more common with a Java doc or a native library API, as I call them, a C++ API. But a web API, it could be coded in anything. So typically you don't annotate the code with something and then render out the documentation as it was more common in the past.
So the developers themselves don't put inline documentation?
They might for their Java classes, but it's not really, or for whatever class they have, but it's not really geared towards the end user. And that's why with REST APIs, it's really important that the docs exist. It's with Java doc, yeah, it was a lot more predictable, standard, more less variety. But with REST APIs, it's more of an architectural style. People don't have to conform to an exact protocol, and things can vary quite a bit. And without the documentation, people are really sunk. And that kind of highlights the importance of a tech writer or a writing engineer. Tia.
So it kind of strikes me as like it's a map. It's like on a map you wouldn't say, oh, but you wouldn't explain this dot means San Jose. It's like the people looking at that pretty much know how to read the map. You need to tell them how to get to where they need to get.
Yeah. I mean, you're not going to find, when you're looking at an API reference endpoint, it kind of assumes that you know how to use that. Normally, the reference part doesn't give you the tutorial kind of information, the handholding that you would expect in help documentation. That is usually put in another part of your documentation, maybe a getting started tutorial or other more conceptual tasks. But yeah, if you just start poking around in like the Twitter API, it's like you kind of have to know, as you say, how to read the landscape, and it assumes a lot about the developer. But there's no really other way to do it. I mean, if you want to write to your audience, it would be really hard to kind of write to a novice audience with an endpoint reference doc. All right, one cool thing that you'll find in request examples is an API Explorer type experience. If you have this is the New York Times API, and you'll notice that if you are exploring one of their endpoints, there's a little option to try it out. And you can put in your own parameters. I already signed up for an API key earlier, but it lets you put in your parameters. And it's cool enough that when you click in here, it tells you what this is. So, for example, if I wanted to find out anything they were saying about Facebook, you mentioned that earlier, it actually dynamically shows you the results, or you could refresh them here. And you could go through these other sort of parameters and populate it. Now, with the New York Times API, this is just a GET request. But these API explorers can also be kind of dangerous. People don't often realize that they're making actual requests on data. So if you have some kind of server with real information and you have like sample users that are buying products or something, it can create a lot of difficulty. For example, I was working on one API. This was like for a mobile app, and the user, when you did a request, would actually order a product, like a recurring order for a product. I'm like, well, how do we how do we show how people can make a request and let them try it out without like ordering a bunch of products?
Sandbox.
And yeah, they had to go and configure a special sandbox with a special test user, special flags in the request and everything. It wasn't default. And at first they didn't even want us to put the request sample in there. They're like, don't show them how to make a request. They're going to actually make requests. I'm like, well, okay.
Why
Don't
do
show
we
them how
have
to
this
use the product.
API?
They can actually use the product.
Yep.
So in testing this thing, would it be advisable for whoever you're doing this documentation for to set up an air-gapped server so
But-
that you could actually do these
Yeah,
things
in
and
theory.
test it on fake data
Uh-huh.
so you don't screw up the real stuff on the real servers?
In theory, yes. You always want a test server and test accounts and test and sandbox. I'm just saying in reality, sometimes it's not that way. And people, a lot, for example, the Watson APIs, IBM has a ton of these. They actually took out the little try it out feature, the execute request, because people weren't understanding that when you put in your API key and you've got your account, it's actually, hitting against your own data. And they were like, oh, now how do I clean it all up? I'm like, you can't. Oh. I don't know all the
Watson will
details of that.
figure it out in a-
Have like a fake product, like flux capacitor,
Yeah.
It's your test products, and these are like 1,000, calls for buying flux capacitors.
You end up with an 85 DeLorean in your truck.
There you go.
Runs on garbage.
Yeah.
So the article search API that you just showed,
Yeah.
which was interactive example, is it based on Swagger or this is the
Yes,
same idea?
yes. Look here, you've got Swagger 2.0 up here. So this is a whole other topic, which I didn't decide to get into tonight because this is more of an intro. But the way that we're going through each of these sections that document the resource URL and the parameters and so forth. There's a whole language set up to describe REST APIs, and that's called Open API specification. It used to be called Swagger, but when SmartBear donated Swagger to the Open API initiative, this like open standard of like people interested in, REST APIs, it became vendor neutral, and they wanted to kind of emphasize that it's not just like belonging to one company. It's not one company's standard. So if you document and describe all this stuff following this Open API specification language, then tools such as Swagger can kind of parse through it, read it, and spit out this interactive display. Now this one is, this is customized. They did something totally custom. You can't really see it all here, but they've got a lot of different stuff, and Swagger doesn't really look like this. This is powered by LucyBot. But there's lots of different tools that can read an Open API specification, and I have a whole section. I'll just show you really quickly on how to create this specification. I think that this is the biggest gap that you can exploit in the API market, is knowing how to create this spec. There's kind of 8 sections in it. There's different objects that you use, an info object, servers object, paths object, and they have different elements that you describe. So I've gone through this meticulously and tried to give a human readable tutorial in contrast to the reference documentation for the spec. And so definitely, that gets more into the publishing aspect. What am I doing with this? How am I going to display it all to the user? And I didn't want to go into that scope, but definitely check it out. Open API specification gives you a format to put all this stuff in. All right, another section that each endpoint reference topic needs is a response example. We showed the request. Now we want to show a sample response. And again, the response is not going to be comprehensive of every different type of response, but it's a sort of representative example. And actually, I just showed you the New York Times one. They had a couple of different ways. You could try it out with your own, or you can also just have this sort of pane here where you can expand and collapse things, which is quite a cool feature, the expand and collapse. But people want to see what comes back because they need to know if it's got the information they're looking for. One thing that's really difficult is how to document a response. This is a sample response in the Dropbox API. And you notice they've got different levels of nesting. You've got an object here that contains stuff and so forth. How do you represent this? Well, the way they've done it is a table, and when you have nested items, they show the nesting like this. But imagine if you have another few levels of nesting, or if you have an array, or if you have a repeating element. like every element shows you a forecast on Monday, and then it has like the temperature, sunset, and so forth every time. How do you?
Like I did that, and I used code comments.
Okay.
So I just did like 2 slashes. This field is mandatory.
Oh.
Whatever it was I wanted to convey to them.
Okay. So you just used
I- so
JSON
in-
code
in
and
the
put it right
sample
there.
Response, yeah, to
Nice.
the right, I just put in 2 slashes, which everybody knows means comment.
Yeah.
And I just made comments like,
Cool.
this field is this, or this is mandatory, or this is whatever.
That's good. Joe?
In an API that I've documented, we just, instead of using an example response, we just used JSON, a sort of JSON meta language that doesn't really say what an example would be, but it tells you what the type would be.
Yeah.
And
Schema.
sort of, yes,
Yeah.
a mini schema.
There's actually a
And-
whole.
And then documented each element of the mini schema in a separate table.
Yeah, I also use schema when I documented just response
That-
and request for post.
Right.
There's a whole site dedicated to how to describe JSON schemas, like a whole organization devoted to this, and it's got its own language and way of representing things. So yeah, if you dig into this, it could be potentially helpful. If you use that Open API specification method I was telling you as well, you would use terminology from that JSON schema to describe it. But it's a challenge to make it readable, definitely. And I like your guys' suggestions. All right. One thing that you'll see commonly is this sort of tri-pane design. Some people love it, and others not so much. But a lot of people like to implement something where you're looking on the left at the object, and on the right, it's an example of all this stuff in context. So here it's saying like, your response is going to contain an ID, an object, an amount. Oh, and I can see exactly what that looks like with an example. And if you can keep these in parallel, it's pretty cool.
Yeah, I was gonna ask how you keep them in parallel.
Well, it's
Especially
some
if
kind
you're
of
using
JavaScript magic. There's a tool called Slate that is sort of a theme built with this tri-pane design, or maybe not tri-pane, that's evokes sort of a help thing. 3-column design. Anyway, it's a common sort of thing. I'm personally not a huge fan of it. I think it's hard to keep those in sync, but if you can make it work, I think a lot of people do like that.
There are tools that just give you that.
Yeah.
That given, you have to set them up, but lots of people have, lots of engineers have gone out to like solve the problem of documenting REST APIs.
Yeah.
And their tools are available for you to download for free. I mean, they make them freely available. You just use them.
Exactly. Thank you. And like I said, Slate is one that has that, but readme.io has it. All right. You also want to list status and error codes. When you get back a response, when we did that curl response, there was actually a status code in there called status 200, which means success. Whereas other status codes like 302 or 500 have different meanings. It's just a way of compressing a lot more information into a number. And these status codes are actually, they're standard. There's a whole page in Wikipedia on these status codes. And they're standard. It goes through like, yeah, these are all standard ones. That's why you really often don't even need to document these, because if you get back a certain status code, 400, well, it just means bad request. That's like what it means. You don't have to explain something that's common knowledge with somebody who's working with APIs. But sometimes companies sort of put secret messages in the status codes, and you can only find out in the documentation. So if you have one of these special codes that's not standard, you want to include it.
Yeah, you get the code and you also get an error response of some sort, in text or whatever.
Yeah, yeah,
They are standard in the sense that they are you're supposed to use a certain number to indicate something.
Yeah.
They're not standard in the sense that servers are constrained to use
you're right,
those
you're right.
numbers.
It's just like a convention.
Yeah, that's a convention.
But for example, you use different like 300 for one type, 300 something for one
Right.
type of errors. 400 it usually like client side
Yeah.
errors that you submitted something incorrect in your request. 500 something is usually server side of errors. If
Yeah.
this server got crazy, like 500 is like internal server error. So this convention in the sense that how your error code starts, like 200, 300, 500, 400, 500, gives you like category of
Yeah.
error.
Yeah,
And
that's
then
true.
Yeah, it's like the first step in troubleshooting, right? It's like, oh, this is a category 500, must be something at the server. It's not my own code. And here's an example. This is, we don't have to go to this. This is with Flickr. They just have a section that lists all their error codes. Now, 100 is invalid API key, so there it's not really a standard sort of thing, but this helps you troubleshoot. And troubleshooting is an important part of documentation, so you definitely want to clue into the error codes. You're never gonna, like, developers will never tell you what the error codes are. You almost have to find them by trying to produce errors. You could ask them, but a lot of times they're embedded throughout their code, hard-coded. Not all developers are so organized that they've like somehow got a whole consolidated list. They may not even know them all. But
How do they ever translate them?
yeah, when they translate them, then they're like, oh crap, I better, recode how I did it. But
So generally, do we want to have error codes
It-
within the
s-
API documentation
it-
or no?
yeah, somewhere.
If they belong to your company's code, but
Yeah.
if you go put in error codes that say are standard for your operating
That's
system,
what you're.
Yeah.
then you're gonna get
Okay.
in trouble when
Got
they
it.
change.
Okay. Thank you.
Yeah, and they don't always appear in every specific endpoint. You might just have one page in your docs that's like, hey, these are all the error codes. Because otherwise you repeat it a lot. But finally, code samples. Developers love code samples, and if you can show little snippets about how to submit a request in Ruby versus PHP versus Java versus JavaScript, more power to you. So here's an example, and this is in, what is this? Forgot. Evernote. So you'll see this a lot with little nav tabs, is what I call these, where you can jump between the two. And here's the thing. These are actually, for the most part, auto-generated. I'm not entirely sure if these from Evernote are, but you can auto-generate all this stuff. For example, Java, right? In Java, the developer is not going to use curl to make the request. They have a specific Java class and library, and this is kind of how they do it. If you go into Postman, there's an interesting little feature called code. It's sort of hidden right here. But if you wanted to make the same request through some other language like Java, it shows you. It gives you the code. You could literally just copy this and put it in there, or Python. But for the most part, most documentation doesn't provide a lot of different code examples like this. If they do, for example, with README.io, I believe they auto-generate it. So if your target users use a specific language, you might, or you might just let the developer figure it out for his or her own language.
If you want to delight your customer.
Well, think about, yes, delighting, but at the same time,
Because we're going to do this, I'm just.
yeah,
Should we care about this or should we not?
probably not,
Okay.
unless you have one specific language that you know that they're implementing it in, then do it. I think it's too much of a maintenance nightmare, and if these are all just generic and auto-generated, what's the point? Couldn't somebody who's actually coding an app figure this out easily enough? But maybe you are delighting them by making it easily copy and pastable. You're inserting their own key and everything.
Of course they want to copy and paste. I mean, they're not living this. They're jumping into this. I'm going to use this thing. They spend 10 minutes on it.
Yeah.
Copy their snippet.
It's hard to
Change it a
go
little.
from the conceptual ideas of the reference documentation that says get, and here's the endpoint, and here's the parameters, to the actual code. And if you provide the code, if you've got the resources to be able to take the time to do that, it helps. But
So-
it's a trade-off.
Here's one thing that I really like. Coming back to Open API specification, there are tools. There's a whole tool. Oh man, why didn't I log in? There's a whole tool called Swagger Hub, which is the commercial version of something called CodeGen and Swagger Editor and so forth wrapped into one. But in this tool, give it a second to load, you can basically take and download. Okay, I must have like cleared my cache and everything. There we go. So let's say that I've got my API on here. Right here, the user. Wait. Here we go. Download. You can download little stub files or files that will help you configure and make all these calls in any of these languages. So there are tools that will automatically generate it in Perl, PHP, Python, and so forth. And so if you've got your API described in that Open API spec, it makes it a lot easier to auto-generate this stuff. But yeah, I mean, it's kind of a whole other topic about how many code samples you want to do. It adds a lot more maintenance nightmare when things change.
Question regarding the previous,
Yeah.
with multiple props.
Okay.
Yeah, this one. So is there some, because I already saw it on APIs of some other company, and this is really cool. And I wonder if there's like some tool that generates those tabs, or you just do it manually in
The
HTML,
tabs
or-
themselves, this is you can do this through like Bootstrap, Zerb Foundation. It's kind of a common JavaScript component. Usually, yeah, try Bootstrap. I think they might be called, they might just be called tabs. I like to call them nav tabs, but yeah,
There also may be a tool that makes it easy for you to just put together code samples with tabs.
Yeah.
I haven't seen it, but
it might be.
take some looking.
All right, but that's more of a, like, how do you publish this information? So we've gone through each of these different sections, and manually putting it together, what would it look like? I have an example in my site where I have users kind of add a new endpoint and go through this exercise of documenting each element. And it might look something like this, where you've got the resource name, a description, what method it has, the parameters, a sample request, sample response, documentation of each part of the response. You got like error and status codes and maybe a code example, right? That's really all you have for each endpoint. And if you have this consistent pattern, people are happy. At the core, that's what developers want. And of course, if you can make it snazzy and attractive and really well put together, even more power to you. But they need the basic information, and that's really what it looks like. I have a bunch of other sections. We kind of jumped through intro, using REST API like a developer, and documenting endpoints. But I've got all these other sections on how to test your API, the non-reference sections like authorization and like rate limiting, how to publish your API. I'm actually giving a presentation on this one there's a new Write the Docs South Bay chapter forming. Yeah,
Great.
yeah. I guess people are getting tired of going all the way down to San Francisco, and so like, let's get a group. So it'll probably be like 5 people, but
Where is this?
Write the Docs South Bay. It's just another tech writing group in the area.
In what location?
I actually don't know. I don't think they know. No, I think a Google place is hosting it. But I'm going to dive into this because a lot could be said about this. The Open API spec, I showed you that. How to document native library APIs like JavaDoc. How to get a job in API documentation. There's actually a great recording on the site, on the SDCSV site, when we had a previous speaker, Andrew Davis, on this topic. And finally, resources and glossary for all the crazy terms. But that is, in a nutshell, an intro to API docs. So any questions that you've been wanting to ask that haven't really gotten to?
Can we get a copy of your
Yeah, of the slides?
Yeah.
Yeah, I already put them. Yeah, they'll be on the regular website. I've also got them here. I put a post on my site mentioning.
You have author rights on the site, so
How do we get of the
Yeah.
post that
you
you
can just throw it
mentioned
on
here?
there yourself.
In the latest post, I've got it right there.
Students API dot course section that you mentioned here.
Sorry, what was the question?
You have to mention some API document course sections.
Yeah, go to my site. Sorry, my site, I'd rather be writing.com. Click API doc right there, and that's how you get to it. And it opens up right there.
You can read all of that.
So,
Yeah.
So in publishing part, do you cover like what tools you use to actually write this
Yeah,
documentation?
yeah. And there are myriad tools. I mean, there are more differences in tools than any other space because it's developer saturated, and they don't really use traditional TechCom tools.
Right. And not only that, but developers by their nature don't like to use other developers' tools. So every time they come up with a problem like documenting the REST API, they invent their own tool for it.
Yeah.
For the top ones do.
Yeah, it's my
Because
favorite one.
They know that they want to have something that none of the other tools have.
But do you have some recommendations or
Yeah.
favorites?
Yeah, my favorite tools. Well, first of all, I love Jekyll. That's my favorite tool. You could do anything with that tool, just about. But that's just one example of a static site generator, and there's sort of lots of different ones. Hugo is very popular, and so forth. If you want an online hosted option, readme.io is quite popular. Although I have heard some people have complaints about it. Somebody, I shouldn't say this, especially since I'm recording it, but somebody was like trying to pitch a job at me, and I was just curious. I'm like, I see they have all these Swagger APIs. I'm like, you know, how do you write this and maintain it? They're like, yeah, we have this in readme.io. I'm like, oh yeah, great choice. You know, like, actually, the first thing we want is somebody to move us off the platform. I'm like, what? But I think they just had some minor glitch that I'm sure they'll work out. There's a lot of work that goes into building a doc site. People do not understand this when they're like, oh, let's build our custom site. Yeah, they don't really want somebody to sink a whole year into theming it. And I think readme.io does a tremendous job at handling all the cases. You can actually write your open API spec and then import it into one of these tools. And that's how I really recommend you do it. Don't worry so much. It's like DITA, right? When you write content in DITA, you can put it in a dozen different tools or more. You don't even have to worry about the publishing format. You have your open API spec, you import it into LucyBot, into RESTlet Studio, into readme.io, into Swagger UI, and it displays it beautifully. Joe.
I was going to say that the big thing is that I found in writing API documentation is to be flexible. You may not have the time to convert what's there into something else,
Yeah.
or to write in the tool that you want as compared to something that's quick and dirty. You may be forced to convert something that somebody else did that is just been done by engineers that needs a month of work just to make it readable. You may run into problems where somebody wants the developer documentation to be in something like a CMS that was designed for writing static websites that it has nothing to do with documentation.
Yeah.
So what you need to do is focus not necessarily on tools, but what sort of things you need to do to adequately document API.
Yeah. Well, the flexibility is huge. Just to comment on that, I know that it is very common for developers to like push out a JSON response to some server and expect that you can just consume it through some script and import it into your system. And if you have some tool that's flexible like that, that allows you to do some custom programming in it, you can really implement more advanced workflows, and developers can help like make that happen. Whereas if you have a closed system that's really locked down, it's just a black box, you can't do anything, you are limited. And that's why I think some people were a little frustrated maybe with that readme.io, is because I don't think you have many opportunities for custom programming. But I could be wrong. It's a double-edged sword though, right? It's like you have an open source platform like Jekyll. Well, there's quite a bit of ways to break it. Okay. All right, so this is the end. You can find me on Twitter, tomjoht@gmail. Be happy to follow up with you.
Where'd
And
your facial hair go?
yeah, my mom told me I looked bad with it, so I took it off. My wife wanted it anyway. Thanks. Oh, thank you.